You should see the executable file somewhere, I guess in your downloads, and I've moved it to the desktop just so it's easy to see. And again, this doesn't require any additional software. This is a standalone executable file that you can run by simply double-clicking it. And that should pull up a standalone window, which might look a little bit different depending upon your operating system. I'm running this on a laptop that has Mojave 10.14 on it, but this is roughly what it will look like regardless of what machine you're running it on. It may be different colors and you may not have all the sounds that you have in this version, but this will be close enough. So the first step is to load a single dataset file, right? And so this doesn't allow for a training testing structure. This takes a single file and runs prediction on it using an algorithm that is described in a paper linked to below the title of this video. And so, of course, you get this annoying pop-up reminding you that you're not supposed to use this for commercial purposes because, again, it is free. So don't do that. There's no excuse to break the law. Commercial version's coming out soon, and it'll only cost $5 a month. So don't steal my software. So the data set we're going to start with is the Uci Iris Data Set, which is also linked to below. And it has to be formatted in CSV format, and the last value has to be the last character in the file has to be the last value of the data set, and there can't be any extra character spaces, nothing. There's no pre-processing available in this version. If it's not formatted in that manner, then the program will just crash. And so I've provided these as examples of how to take your data sets and format them so that they work with this version of the software. But it's just a CSV file with no extra spaces or characters. So the first step is to select that file, and that will automatically load. And then to select the output path, which is where you want the prediction file to be written, right? So once this program runs, it actually saves all the predictions and prints them to a plain text file. And so I've set up a folder, Black Tree Output, to store it, but you can send it wherever you want. You don't select the file name, you just select the folder that you want the output sent to, and it will automatically generate a file for you. As you can see, some of them have already been generated, and you're basically guaranteed a unique file name every time because it pulls the current time, including the second that you run the prediction. So you should get a unique file every time you run it. So then you hit open, and then you hit run prediction, and you'll see that it says processing, and it's already done in this case, as this data set consists of only 150 rows. So then we go to our output file, Black Tree Output, and as you can see, it's 919, so this is the last output generated. And so you can see for every row, there's a predicted class, right, which is what the algorithm thinks the prediction is, and the actual class, which is the algorithm checks after it makes a prediction. So it's done on an unsupervised basis. There's really no training step, and if you want to read about how the prediction algorithm works, see section 5 of the paper linked to below. So the name of the data set is up top, there's a timestamp just below that, and then all your predictions follow below. And then at the very end, you have the total number of errors and the accuracy, which in this case is 100%. So let's load another data set where we'll actually make some errors and take a little bit more time as it's a larger data set. So we're going to now load the UCI Ionosphere data set, which has about 350 rows. We're going to keep the same output path. So I didn't have to do this, but I did it anyway, right? So if you just leave the output path as it is, you'll get prediction sent to the same folder. You don't need to select it every time. All right, so now you hit run prediction, and you'll see it says it's processing, the accuracy is pending. You might get a pinwheel, but that's okay. It just means it's working, it's fine, the program won't crash, as long as your data set is formatted properly. So just give it a minute or so, and it should finish up shortly. And that's it, it's done. And as you can see, the accuracy is also printed here, just as a summary, and in this case it's 99%, so there were some errors. So let's pull up the file, right, so it's 920, this is the most recent, and as you can see, the name of the data set is up top, Ionosphere data set, and with the timestamp below that. And so, scroll through the predictions, you'll notice that some of them have an asterisk next to them. These are the incorrect predictions, right? So the predicted class was 2, the actual class was 1. That's an error. The predicted class here was 1, the actual class here was 2. All right, so all of the errors will be flagged with an asterisk in the output file. And in this case, we have a total of 3 errors for an accuracy of 99.1453%. And so that's really it. So now let's say I make a mistake, right? So I forget to select the dataset file. What happens if I hit run prediction? Error. right? That's it. Right? So it just reminds you. Same goes if you forget to select the output path. And then this button here is the help button, which actually simply brings you to this video. And that's really it. The next version will be a paid version and will include pre-processing such as data normalization and other pre-processing that will bring the algorithm, bring the software to a truly professional level where you can do real machine learning in basically an instant using a point-and-click interface with, as you can tell, very high accuracy.